So here we have a typical tow bar eye arrangement, and the customer was interested in knowing where the strain gradient was occurring in the actual metalwork when it was loaded and bolted to the back of the vehicle. And they knew that the strain peak was somewhere across this area here, but they didn't know exactly where it was. So we put on here a micromeasurements strip gauge, which has 10 gauges all on one backing, and then wired as 10 individual quarter bridge strain gauges. When the appliance is then actually loaded, of course, you can then measure those independently on a data acquisition system, and you can see, of course, exactly which strain is the highest as we load this, as it would be used in service. So what we see here is this gauge will probably see a lowish strain, getting up towards a higher strain in the middle, and then tailing away again to a strain which is very low on the other side. But eventually we will know exactly the distance that the actual strain exists over on this face of metal here. And then we can choose an individual strain gauge to actually sit within that gradient and measure the total strain that's there. Bear in mind with strain gauges, if the strain gauge bridges a strain gradient, then you only get the average strain. But if you want to measure all of the strain, you need to have the strain gauge sitting entirely within the gradient. And that was done here, and it was very successful. They found exactly where the high peak strain was, and they were able then to put on a single strain gauge and take it away and put it into service on a car, and put it through various tests to find out why this was actually failing across these two joints here, or these two holes, should I say, where it's connected to the vehicle. And when the tow bar gets a pull on here, if these are not completely equal, then of course you get bending, and that creates the gradient.